having a good week. Sorry for the late videos, but let's go ahead and get to the chapter 9 notes. We're going to be starting with C.1.1, which is actually from our appendix, but it's all about the same material from chapter 9. So let's go ahead and get to the notes. Okay, so I have a few things already filled out. So if at any point you want to just pause it and write down the information, you totally can do that. But we're going to start with some of our basics that you should have already known, but just a little bit of a refresher. So the mean of the data is the average of all of the numbers. So you add them all up and then divide by the number of data points that you have. The median is if you put all of the numbers in some sequential order, it's going to be that middle number. And then this should be the number that appears the most. And then the range is the difference between the largest and the smallest number. So when we're looking at histograms, it's similar to a bar graph, but not. But now the x-axis is the intervals instead of the category. And so if you look up here, we have the interval. So from 0 to 15, all of those numbers would go into this bin. And then our y-axis is the, I'm trying to see where it's at on here, but it's the frequency. And so our frequency, so this is how many times these numbers appear in our data. And so where would we place the value 15 in the histogram? That would be in the 15 to 30 bin. And then we would place 75 in the 75 to 90. And so how many data pieces do we have? So even though we don't have the data in front of us, we can still figure out how many data pieces we have, because this would be, there's 12 in the first bin, then there's 10 in the second bin, 6 in the third bin, 8 in the fourth bin, and then just 1 in our last bin. And so if we add these together, we would get 37. And then we're not going to worry about this last question. Okay, so let's go ahead and create a histogram. And so what I suggest doing is, even if and so we're going to talk about how your calculator can do a lot of the work for you. But if you're creating a histogram, my suggestion is to take your data points. So our data points are right over here. And then write them out in sequential order, so that way you know how many we have in each bin. So it says that your bin width, you want to be 8. So if we start that this is 20, so then that would mean that this is 28. Then this would be 36, 42, 50, and 58. And then we're just going to make this 1, 2, 3, 4, 5, 6, 7, 8, 9. And so I know that I really only have to go up to 58 because our highest number is 55, so I don't have to go any higher than that. So I'm going to write out my data points in sequential order. And so I have 20, 20, 20, then 23, 27. Another 27. 30. 31. 34. 34. 35. 37. 38, and we have two of those. 42. 46. 49. Oh, I forgot my 39. See, this is why it's good to mark them off. 39. 42. 46. 49. 52 and 55. Okay, so now that we have all of this, we can go ahead and make our histogram. And so in my first bin, that's going to be 20 to 28. So I have 1, 2, 3, 4, 5, 6 between 20 and 28. So then that means that I'm going to go up here to 6. And so then I shade in this whole bin up to 6. Then from 28 to 36, I have 1, 2, 3, 4, 5. I'm going to go up to 5. And shade in to 5. Then from 36 to 42, I have 1, 2, 3, 4. I do not include 42 in this one. That will go into our next bin. So I have 4. And then from 42 to 50, I have 3. 1, 2, 3. And then from 50 to 58, I have 2. And so this is also fine if instead of you shading, you just want to have boxes like this. That also works. Yeah. So for our mean, we're going to type all of these numbers into our calculator and find the average of them until we get that our mean is 34.85. And then our range is 55 minus 20, so 35. Okay, and so then I want you guys to try this one. I will put the answers in this OneNote document so you can look at the answers later on, but I want you guys to go ahead and try this one. Now we're going to talk about making a box and whisker plot. And so with a box and whisker, it's also called a box plot, but we use our 5-number summary. And so the 5 values that make up our 5-number summary is the minimum, the first quartile, our median, sorry, this should be a 1, not an L. Quartile 3, and our maximum values. So if we line up these numbers, so this is what a box and whisker plot should look like. This one up here does not go with this data, just so you know. It looks kind of similar, but it doesn't go with it. So I'm going to line up my data points in order. So this is going to be 1, we have 2 2s, 2 3s, 3 4s, 3 5s, 6, 7, 8, 9. Okay. So we can tell from this, our minimum value is 1. Our maximum value is 9. Then we want to split this up. So if we go 1, 2, 3, 4, 5, 6, 7, 1, 2, 3, 4, 5, 6, 7, that means that this is our median. That is our middle number. Now, I know that each of these have 7. And so if I look at this, I want to find the middle number of this. And so that would be my 3. And I want to do the same thing up here. I'm going to find the middle number, and so that is 6. And so that's how we find Q1 and Q3. Then the mean, again, we add all of these up together, and then divide by 15, because that's the number that we have. So this is going to be 4.83, or sorry, 4.53. And then the range is 9 minus 1, so that would be 8. So then on our number line, I'm going to go ahead and number these 1, 2, 3, 4, 5, 6, 7, 8, 9. And so at our minimum, maximum, we put our points, and then 3 and 6 and 4. And so basically we're going to have a line, we're going to make a box in between our Q1 and Q3, within a line at our median, and then we just connect the maximum and the minimum to our box. And so that is our box and whisker plot. And then we have one last value to talk about, and so that is our interquartile range. And so basically 50% of our data falls between Q1 and Q3. And so if we find the difference between Q1 and Q3, that is our interquartile range. And so for this data here, if we take 6 minus 3, so Q3 minus Q1, we get that IQR is 3. Okay, so again, so now let's see where we can get these numbers in our calculator, because if we have a small data set like this, we can easily write it out, find our median, find our Q1, Q3. However, if we have a lot of points, or if they're just bigger numbers and we don't feel like doing it, our calculator does this for you. So here are the steps. I'm going to switch over to my other screen so that way you guys can see how to do this on the calculator. So I'm going to walk through this with your calculator. Hopefully have the notes in front of you, and then we'll go back to the notes. Okay, so what we are going to do is you first go to stat, and then we want to hit enter to edit. Now, if you have things in your L1 and L2, we're not going to be using L2 for these data for what we're going to be doing for this chapter, but regardless, I like to clear it out. So you go up to the top, hit clear, enter, go over to L1, hit clear, enter, and then your data sheet is cleared. So then we want to type our data all into L1, and then remember to double check your numbers. So we have 13, 30, 30 again, 35, 36, 15, 20, 21, 23, 29, 36, 37, 37, 45. Okay, so if you see at the bottom, it says L115. And so that means that we have 14 data points. Let's just double check. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14 data points. So I know that I have the right points. For a lot of these, we will also put a sum check, just so that way, whenever you do your do this process, it'll tell you what the sum is, and so that can double check that you have entered all of your numbers correctly. So once you have all of your data into L1, you go back to stat, and then now we want to calculate one variable stats, and then you just hit enter until it calculates it for you. And so in your notes, we have this guide that lets you know what is what. And so this top one, the X bar, that is our mean. And so that means that the mean for this data is 29.07. And then, so then it tells us our 5-number summary. And we'll talk about some of these other points for standard deviation and stuff like that here in a little bit. But the last 5 on our calculator are our 5-number summary. So the minimum is 13. Q1 is 21. The median is 30. Q3 is 36. And the max is 45. So then the range is going to be 45 minus 13. And so that would give us 32. And then our IQR is going to be 36 minus 21. And so that would be 15. Okay, so going back to the notes, so that's the data that we use from our calculator. Okay, so now for our number line, so I'm going to start at 10 and then go up by 5. Okay, so then our minimum value is at 13, so that would be about here. Our maximum value is 45. Our Q1 is 21. Our median is 30. And our Q3 is 36. So then we draw our box. Let me draw that a little bit better. And so that is our box and whisker for that data set. Okay, so again, I want you guys to try and do this. So you can type this data set into your L1, find your 5-number summary, write down what your mean, range, and IQR is, and then make your box and whisker. Okay, so now we have just a lot of vocabulary. So with our data, if we do a histogram, then we're going to analyze the data based on 4 different things: the shape, center, spread, and outliers. And so today we're going to mostly be focusing on shape, center, and spread. And so the shape is described by 2 things. One, we either pick if it's uniform, single peak, or double peak. And so uniform is if the bars are pretty similar height. A single peak is where the data has a single area where it's highest. And then a double peak is if there's 2 peaks or 2 areas where the data is the highest. And so we pick if it's uniform, single peak, or double peak. So that's 1. And then we say if it's symmetric or skewed. And so symmetric means that it looks the same on both sides of the peak. Skewed means that it falls heavily to the left or to the right. And so if our data is skewed to the left, that means that it looks like your left foot where the peak is on the right. And so what this means is if we have our data set, it means that our peak is further to the right. So this would be left skewed. Then right skewed looks like your right foot. And so that means that the peak is on the left. And so if we had our data set looking something like this, our peak is on the left, but because it looks like our right foot, that means that it's skewed to the right. Now, this is a little confusing. I get that. I sometimes still get them mixed up in my head. But thinking about if it's left skewed, it looks like your left foot. If it's right skewed, it looks like your right foot. So then if we want to describe these, this one would be symmetric. And so if it's symmetric, it's always going to be, sorry, this is a uniform symmetric. So it's uniform because it's pretty well straight across, only a few. And so anytime that it's uniform, it has to be symmetric. This one, if we look, it has 1, 2 peaks. So this is a double peak. And then it's fairly symmetric. It's a little higher right here versus here, but that's fine. It's still going to be symmetric. And then this one has a single peak, and it's really nicely spaced out on either side. So this is single peak. Symmetric. And then this one is a single peak, but it is skewed to, so because our peak is on the right, this looks like our left foot, so this is skewed left. Okay, I apologize for my handwriting. My stylus is not cooperating. Okay, so then that is our shape of the graph. Now we're going to talk about center and spread. And so for center, these are already given to you. So the center is either the mean or the median of the data. And so the mean, again, is the arithmetic average of the data set. The median is the middle number. And so we use the median if there are outliers. And so outliers is where it's skewed and not symmetric. And so outliers are where there's, let's say our data is mostly between like 10 and 20, and then there's one outlier where it's 35 or something like that. So basically it's a data point that sort of doesn't act like the rest of our data. And so then we use the mean if it does not contain outliers. And then, so if it's symmetric and not skewed. Okay, so that's our center. So basically, when we look at our data, we want to see, okay, do we have outliers or is it more symmetric? And so the first thing that we do is decide if we should use mean or median. Then we look at the spread. And so the spread is how much the data varies. If the spread is a large number compared to the data point, then the data has a large variation. If the spread is a small number compared to the data points, then we have a small variation. And so basically, for the first, or for the second box and whisker plot that we made, where it was the first one, where it was 1 to 9, we had 15 data points, but then our range was only 8. So that would be a small variation. Yes. Okay. So now, if we're talking about our spread, so don't worry so much about the variation. Basically, we first want to determine, okay, should we use mean or median for our center? Then, depending on what our center is, we choose whether we want to use the IQR or standard deviation for our spread. And so again, the IQR is the difference between the Q1 and Q3. And so we use the IQR when the median is our center. And so we use standard deviation, which we're going to talk more about, if the center is the mean. And so the standard deviation is the square root of the average of the differences to the mean after the differences. It's a long definition. Basically, right here, this is how your calculator calculates the standard deviation for you. So there's two different ways of calculating standard deviation. There's population and sample. We are mostly going to be using the sample standard deviation, or sorry, the population standard deviation. So it sort of looks like a weird O with a top. I believe this is a lowercase sigma, but that is the function, or that is the number in your calculator that we want. Now, for outliers, you probably already know what an outlier is, but this is data values that are far away from the bulk of the data distribution. And so the data values do not match the pattern. So like I said, if most of our data is between 10 and 20, and then we have one that's at 35, that would be considered an outlier. And so basically you always want to look at your data, make a histogram or look at a histogram, and then if something is way off in like left field, then that is going to be your outlier. So that is all the notes I have for C1 and C2. Have a great day.